2 years ago, an article entitled Hour of Time and its Reversal on the IBM Quantum Computer was published. The article explained how the physicists used a quantum computer to simulate an event that amounted to the reversal of time. The simulation was entirely accurate, arriving at a conclusion that is valid in the real world. I'll be explaining how this worked and why it is important by introducing you to entropy, the hour of time, some quantum physics, and quantum computing. Entropy is the disorderliness of a system, from an electron to the entire universe, and it always increases. The reason is probability. There are only a few ways for a system to appear organized, and far more for it to be disorganized. Consider the breaking of an egg. There are many more ways for it to be broken than to be whole. Because of this, entropy creates the arrow of time, the best explanation we have for why time works one way but not the other, why the egg can never be unbroken. The entropy is higher when it's broken than when it's unbroken, so while it's theoretically possible to unbreak an egg, it's so unlikely that it may as well be impossible. To understand how our hypothetical egg relates to this experiment, we'll have to understand a bit of quantum physics and how quantum computers take advantage of it. Like the increasing of our egg's entropy, the entropy of any particle on a quantum scale increases, automatically. This is known as smearing. When a quantum particle's location is observed, what is known as the wave function, or all the places the particle could be, collapses, as it chooses one location. Our instruments are not inaccurate, rather they actually were in all those places. Though observation collapses the wave function, over time it spreads out again. That is what was simulated. But it was so controlled that the smearing could be reversed, decreasing entropy. Technically, this isn't turning back time, but it is the equivalent. It's like if we took a bowl of scrambled eggs, did some calculations, and then shook the bowl in such a way that the egg unscrambled itself, then reassembled itself into a whole egg. And no laws were broken. Remember, the increase is based on probability. How is this accomplished? The quantum computer, like all quantum computers, used qubits for its calculations. Instead of bits, which are 0 or 1, a qubit is a 0 and 1, with varying degrees of probability until observed. Though in other ways they are comparable with a normal computer, this feature makes quantum computers very useful for simulating quantum occurrences. In this case, the spreading of an electron was simulated by setting 2 to 3 qubits to act not only with uncertainty, but in increasingly complex ways. Because the qubits followed the laws of quantum physics, when the simulated wave function was reversed, not collapsed, it was equivalent to the event really taking place. So, to recap, we learned about entropy, why it always goes up, and how it creates the arrow of time. We talked about some quantum physics, how they govern quantum computers, and how they interact with the arrow of time to cause smearing. Lastly, we saw how this simulation was created, and why it is relevant. Thanks for watching. I hope you enjoyed this video.